some different firewall architectures that we should talk about. They can be configured in a number of different ways. Each firewall device noted previously can be configured in a bunch of different network connection architectures. The firewall configuration that works best for a particular organization depends on three things, really. The objective of the network, the organization's ability to develop and implement the architecture, and obviously the budget available for the function, because these things have to be managed. There are literally hundreds of different variations of network architecture, but the four common architectural implementation of firewalls is packet filtering routers, screened host firewalls, dual homed firewalls, and then screened subnets. If we look at the first type, the packet filtering router, most organizations with internet connections have a router as the very first device to the that traffic from the internet would reach. So that a border router creates that original or that furthest perimeter. Many of these routers can be configured to reject packets that organizations do not want to allow into the network, which is really what they should be doing. The drawback to this type of system includes a lack of auditing and strong authentication, and the complexity of the access control list used to filter the packets can grow and really impact, degrade network performance. So we don't want to just rely on packet filtering routers as our only line of defense. So if you imagine a network, the very first device that you would run into would be a packet filtering router, which would be deflecting traffic that's not specifically directed at your organization's network. But it cannot be and should not be the only layer of defense that you have. And here's a little image of a packet filtering router used as a first generation firewall, and you can see that it is the furthest device away from your trusted network. And then this particular picture, there's nothing else behind it, so it's blocking data packets that are not specifically designated for the internal network, and its unrestricted data packets are allowed to go out. Second type that I had mentioned is the screened host firewall. And screened host firewalls combine packet filtering routers with a separate dedicated firewall. This is a bit more secure, like an application proxy server, which allows the router to pre-screen packets, minimize network traffic for the load on the internal firewall or internal proxy server. The application proxy examines at the application layer protocol and performs the proxy services, which seems kind of fundamental. And this separate host is often referred to as a bastion host or a sacrificial host. In other words, it can be a rich target for external attacks and therefore should be very secured. You're going to want to remove any unnecessary services. You're going to want to make sure auditing and logging is turned on so that you can see what's going on and be able to recognize an attack when it occurs. Here's again another image of you have a packet filtering firewall or application level firewall that's being used as the initial filter, pushing things to the bastion host before it's allowed into the internal network. A little bit more secure, a little bit more functional. Dual homed hosts, basically with this approach, the bastion host contains two network interface cards, one connected to the external network or the untrusted network, and the other one connected to the internal or the trusted network, which provides this additional layer of protection by requiring all traffic to go through the firewall to move between the internal and external network. The firewall or the protection is the break between the two network interface cards. Implementation of this architecture often uses network address translation mapping, assigned IP addresses to specific ranges of non-routable IP addresses. That 10 series that I showed you is an example of one of them, creating another barrier for intrusion from external attackers. And a little grid of reserved non-routable address ranges, things that we would expect to see on internal networks. You got the 10 series, the 172 series, and the 192 series. And then you'll see the decimal marks, the 255s series on the end. Here's a picture of a dual homed host external filtering router, right, which pushes traffic away that's not specifically designed for are specifically designated for the network, and then you have a dual homed host with two network interface cards, which is one for the external network, one for the untrusted, and then one for the internal, and then an additional internal filtering router which directs traffic into the internal network where it wants to go, but it also used to block internal data packets from going out that are not permitted to. Screen subnet firewall is really probably the most common that you'll see now, and when you hear screen subnet, you should be thinking DMZ, which is a dedicated portion of the network linking a single bashing host, and it can be connected to the screen subnet. So if you think of the DMZ, you're thinking of an area semi-trust. Right? Common arrangements here find the subnet firewall consisting of two or more internal bastion hosts behind the packet filtering firewall, each host protecting the trusted network. Connections from outside are routed through the internal filtering router, and then routing firewall to a separate network segment known as the DMZ. Connections into the trusted internal network are allowed only from the DMZ bastion host servers. So the screen subnet is an entire network segment, really provides two functions, right? It protects the system, DMZ system, and information from outside threats by providing a network of intermediate security, and it protects the internal network by limiting how external connections can gain access to the internal system. DMZs can also be used to create extranets. That's just a segment of the DMZ where additional authentication and authorization controls are put into place to provide services that are not available to the general public. Subnets really, again, the two functions, again, they protect DMZ systems and information from outside threats, and they are used to limit how external connections can gain access to internal systems. And I had mentioned previously about the extranets. SOC servers is the protocol for handling TCP traffic via a proxy server, proprietary circuit level proxy server that places special SOC's client-side agents on each workstation, and they require support and management resources beyond those of a traditional firewall. So it's a little bit more secure, but it also provides or requires additional support. Here's a representation of a screen subnet. Again, you have your untrusted network, external filtering router, bounces traffic away that's not specifically designed or designated for the particular network that we're working on. We use a firewall to create a DMZ or a screen subnet where we have perhaps some servers out here that we want to have limited access to from the outside. Maybe it's our web servers, our STMP servers, or maybe we have antivirus servers sitting out there. This firewall here will direct traffic out there, and then internal filtering router protects or provides access control to our internal network. Only traffic allowed through this firewall as those are specifically designated to come into the internal network. This is an area of semi-trust. This is an area of untrust. This is our trusted network. So, when we talk about selecting a firewall, what we want to think about, or some of the questions that one would want to ask is, the most important of these is to the extent to which the firewall design provides the desired protection. In other words, what types of firewall technology offers the right balance between protection and cost for the needs of the organization? What features are included in the base price? Which ones are not? What features are available at extra cost? And are all cost factors known? And when we talk about determining cost factors for firewalls, we also have to take into consideration, do we have an individual within the organization that is qualified and capable of managing this device? Or are we going to have to hire somebody? Or are we going to have to take that individual and get them some training in order to properly manage the device? Keep in mind, it doesn't do us any good to put a device on the network that's not properly managed. It's just setting us up for failure. How easy is it to set up and configure the firewall? How accessible are the staff technicians who can competently configure the firewall? And can firewalls adapt to the growing network of the target organization? In other words, can it grow with us, or are we going to have to replace this if our network gets big? And then, the second most important issue is cost.